Okay, let's talk about networking and TCP and net and all those fun things. We did a little bit of it this last little module. We didn't do a lot, and we don't do a lot of networking because we're learning to be web developers. So we don't do a lot of direct networking, but it's good to know what it's doing because it does affect what we do later on. We get into things like a TCP. So quickly review a few things, why we need to know this stuff. We'll talk about the client server, should be the client dash server model. And then quick protocols, done this before. TCP node, we'll do our another client server app. And then we'll say, how the heck is any of this related to web development? And a little bit about application protocols, because this is where it actually starts to make sense to us. So I know we've all seen this diagram. OSC model diagram. I remember I went to a course, this is years ago. I've been developing for 45 years. So back in the 80s, they sent me on some course to Ottawa. I like basically partied in Ottawa because like the bars they open till like 4 in Hull. They close at like 9 in Ottawa, but they all open in Hull like about like 1 a.m. So it's great. So I dragged myself to the classes. It was like I think a 1 or 2 day class. And I remember the guy putting this thing on the screen. I was just like falling asleep, like, oh my gosh. Physical data link. Oh, what is that? Okay, what? So the only thing I got out of that entire weekend was there is a thing called the OSI model. I think I say OSS model or CIA or whatever. I can't even get the acronym right, but I know there's some kind of 7-step model that describes networking, and that's all I knew about networking like for years, and I did just fine. So it's not something we really need to know about because I survived. There's another way of looking at it. It's this way, looking more like a TCP/IP, and this makes more sense. We have the links. This is stuff like Ethernet cards, Wi-Fi connectors, cables, fiber optic, that stuff. This is like the really stuff that we just plug in. Then we have the internet, which is like the IPs and transport. This kind of goes together usually, TCP/IP. And this is how we communicate between devices at a relatively low level. And that's what we've done the last week or two is that kind of networking stuff. Then on top of that is the stuff we actually care about as web developers. HTTP, HTTPS, FTP, all these application protocols. And these are protocols that are being developed and are considered standards. So we really care about this, but it's good to know a bit of this stuff because we might be asked to do some socket programming. Or later on, we maybe do some web sockets, which is very, very cool. So what do we need to know? Not really much. It's good to know for networking. So all we really care about in networking is the three things: the host, the port, and the protocol, which is usually TCP. And that's really all we need to know about this entire thing, pretty much from here down. We don't care too much about if it's a network card or a Wi-Fi card or who cares, right? And we don't really care about the packets that are going back and forth. I don't care about that stuff. Um, at least unless I'm doing some actual fiber optic stuff. So as developers, we really care about barely into this level, the TCP level, just barely. We kind of dip our toes, and then for the most part, we stay up here in the application world, HTTP programming, which we'll be doing next. So this is really all we care for networking. There. That's kind of all that we care about is those things. It's nice to be aware of it, like know it's there. So no OSI. Did he spell it right? Is it OSI or OIS? It's OSI. I got that right this time. Model exists. That's kind of it. So you can tell your grandchildren, yeah, there's a thing called the OSI model. Oh, yeah, what's it do? I have no idea. I just know it's there. And that's really all we need. Okay, so, but we need to know these. We know when we connect to a server or we have host and the port and sometimes the protocol, but usually we assume it's TCP because most of what we do is TCP, because these protocols, as we know, there's a few of them. And these are the low level, we'll call them network protocols, not to be confused with the application protocols, which are things like HTTP. There's really only a handful of them, and we only care about UDP and TCP. And those are the two ones we really even need to know about. Lots of other ones, but for the most part, we just worry about those two, and that's it. And of these two, this is the one we actually work with the most in web. This one's kind of cool. If we do things like communication, uh, like we're talking now, we are talking now over UDP. It's a connectionless less type of protocol. And it's good for sending large amounts of data that you don't really care that much about. Like, who cares if one pixel on my screen disappears? I don't care. Gives me a zit in my face, but it disappears in a second. So who cares, right? So it's usually used for this. You send data and you forget about it. You don't even care if it got there or they're even in the right order. TCP, of course, is much more strict. It's like guaranteed. How do you spell guaranteed? Teed delivery. It's like the FedEx of the protocols. You're guaranteed to get it. They give you a tracking number, and you can know that it got there. I think it's guaranteed. That's right, isn't it? Guaranteed. I think so. Okay. So it's guaranteed delivery. All these cool things, but it's also expensive. Anyone ever sent a FedEx package? It's pretty cheap as opposed to a Canada Post. We'll call Canada Post UDP. Connectionless. It might get there. It might not get there. It might not get there for years. It might get there in the wrong order. It's just not guaranteed. But it's a lot cheaper than FedEx or even UPS, which is more expensive, but they're guaranteed delivery. Okay. And that's really all we care about for networking. So for all this stuff, from here down, that's all we care about as web developers. But we've done a bit of work in it, so we'll do a bit of coding. We know there's a thing called the client-server model. Now, this we do care about. This is actually very relevant to us as web developers because we are all about this. The client server. Who's the client? Who's the server? And it's really good to keep that in mind because this will become more and more important as we move farther and farther along the program. It becomes less clear, well, am I working on the client or on the server? Which one am I working on here? And our first project, which starts in a little while, will be doing mostly server-based applications, but it still runs, part of it runs on a client, right? So think of it, the client server, it's like a phone call where we have the caller and what's the person who's called? Call E? That doesn't sound right. Maybe the called? I think it's called the called party and the calling, if I remember the calling party and the called. So this is the client, the one who initiates the call, and this is the server, the one who listens for calls or wait for calls and answers them when they get called. So that's client server. And we've seen this before. Looks like this, right? Clients, web browsers, phones, this pretty much anything that can do a connection, and then servers that have server software that answer. And as far as we're concerned, there's always these two sides. Bit of a caveat to that, you can write client-only software, and we actually do that with jQuery and React. They run only on the client, but they do occasionally talk to a server to get information. Because you can run an app on your phone, can't you? With no internet, like on a plane or something, it works. But as soon as you want to do something, it doesn't work. But the app comes up, it does run, but it can't talk to any server because you're out of range. But this client server model, this is ingrained into us, client server, and knowing which the client and which is the server, and which is the client program, and which is the server program. And this is really important. All right. So why do we care about any of this stuff? How is this related at all? Well, it is related in that we do have browser apps and server apps. And that's what matters to us. We have apps on the browser and apps on the server. We'll start off, I believe, the next module writing our first app. Have we guys started your first next module yet? We're still finishing off the module with the async and promise. I believe the very next model, we write an application called Tiny App, which is pretty cool. It's actually finally we get to write a real web application. Thank goodness, after all those weeks of low tide and snakes, which is kind of cool. Got to admit that. But then other stuff is a little boring, not so great. But now we get to write a real browser app. And that's going to be a browser app that runs on the server. And our browser just requests pages. And that's how it works. So we have the server and the browser being the client, it simply requests a page and it gets a page. It doesn't run the page. It's just a static page. Just like think back in like the 90s or 2000s when the internet was like brand new. We had these static pages with these blue links. Very cool stuff back then. Seems primitive now, but that's all web pages were. The browser would go to the server, would say, hey, give me this page. The server would say, great, there's your page. The browser shows that page. You click on a link, the browser sends another request. Give me another page, and so on. That's how this client server works. And that's how we're going to start off our journey on web development here. So really quickly, there's one more thing to talk about. We'll talk a little more in a few minutes. OSI, we'll talk about these particular protocols, application protocols, and we'll talk about that at the very end if we have time. Let's go ahead and make ourselves a really simple, we've done this before, I know, a simple client server. And this will become important later on when we start doing WebSocket programming. And it will look an awful lot like what we're doing right now. Now, we've already written one client server pair quite a while ago, client server JS. And we wrote our Snake client JS, which was kind of fun. This was a game of some kind. So we'll do the same thing here, a very simple version of that. But we're going to write both sides. We're going to write the server and the client. So make yourself a little file really quick. It's server.js. There. And the module that we use is net. Net is actually TCP. Remember, there's two generally. There's TCP and UDP. Well, to talk to TCP stuff, we just use this net. There is another one. It's called dgram. We don't use it for much. That's for doing UDP stuff. I will send a link to this and the master branch right there. It will have a copy of both, a client server in TCP and a client server in UDP if you're interested, because it's kind of cool. Because UDP, you just like toss out your stuff. No connection, just spew it out, and the server just like grabs it and prints it. It's like super simple. But we won't do that today. We'll just do TCP for today, but it's kind of fun. So there's our net. And we do know that to make a server, const server, we just do a net.create server. Just like that. There. And we get this server object. There. That's how it works. And what is this thing? Well, that's actually a, and the server. Let's take a look. Okay, so it is, okay, so it's not based on any object. It's just, or not based on any class. It's just a regular object with some stuff that I have no idea what that means. No clue. But it allows us to have a server that we can now listen. This server can now listen for connections. What we normally do is you go server.listen. And we listen on some port, 3000, as good as any. And that's really all we need to do. Just listen on port 3000. And now this server is listening on port 3000. Let's give it a try. It should now listen. There, I now have a server. Hooray. It does absolutely nothing, of course, but it is listening. Control C that, it stops. Great. So Net is kind of cool. It's a pretty big library. It's actually built in to Node. There's all kinds of cool things here. Look at this. There it is, server.listen. So this stuff's all documented. Not the easiest to find, but it is there. So there's the server. I can go listen, right? And we get all these events. So I called server.listen. I could have given it a callback, it says. If I give it a callback, it will tell me when it's actually ready. I could try that. What the heck? Let's go give it a callback. I'll use an arrow function. There, I'll just console log listening. There. See if that works. There, listening. Cool. Okay. And you get all these events. This is called event-driven development, where you have an object and it sends you events. Just send, and please stop the program. So it's going to send all these events. Well, looks like it'll send me an event when it starts listening, which kind of defeats the purpose of having the callback, doesn't it? Cool. Okay. It'll send me an event when it gets an error of some kind. But what I care about, it'll send me a connection or an event if somebody connects to me. That's what I really care about. It sends a connection event. Admitted window connection is made. Cool. Okay. And you get a socket back. So let's try that. Now, this could be anywhere. I could put it here, dot, okay. And I'm going to get a on, right? It's always on. You listen on, okay? And you tell it what event to listen on. It'll be the connection. And when you get a connection, there. And I can just log someone connected. So this stuff's pretty easy. There's actually no promises or anything. It's just event and then callback, event callback. So pretty easy to program. It's really, I find this actually much easier than doing other kinds of programming because it really is so straightforward. It's just event. So someone connected. There. Let's take a look. Run my server. Well, I got to test this. I want to test this thing. Well, the cool thing is built into almost every system, certainly Linux, you have a program that does exactly that. It's called Telnet, and we use it all the time. Telnet. And you can tell it, I want to connect to the local host on port 3000. Oh, look at that. Someone connected. So I can test my server using Telnet. Telnet's pretty much baked in. Control, there we go. Oh, control slash. There we go. There we go. It's pretty much baked into every operating system, or it's easy to install because it's a basic Linux or a Unix utility. It saves us having to have a client program to test our stuff. We'll write a client in a few minutes, but at least I know I can test this stuff that got a connection. Very cool. So it's event driven. And now this is asynchronous. How does this run, by the way? Let's think about this. What happens if I'm going to console log right here, starting here, and let's put at the end here, end. Let's run our server and see what happens. Remember, JavaScript is a single-threaded, non-preemptive language, which means it can't do more than one thing at the same time. And that's really important, which means when I run this, I get starting and end. Look at that. It blasts through all this code all the way to the end. Done. And then things start to happen because we know, because with async operations, they will never happen when JavaScript is busy. Nothing will ever happen ever, really ever, while JavaScript is doing something else. We'll always wait until it's finished. So it runs the whole thing. Then now it's not busy. Now I can say, okay, any events happening? Oh, this thing finished this thing. I get this. Maybe somebody connects. I get this. But none of that can happen until JavaScript is finished whatever it's doing. That's a really critical thing to know about asynchronous programming. And it really is great to think about that. JavaScript will never do anything until it's not busy. It will never do things in between two lines of code. That can't happen. Other languages, sure, C, Java, they have really cool multi-threaded capabilities. JavaScript does not. It is single-threaded. Can't be interrupted. So that's why I get starting end, and then my events start firing after that. We don't really need that, so we'll just, okay. So now, and by the way, this can be in any order. For that reason, I could put this here, can't I? There. It doesn't matter because it runs everything. It sets the listen, it sets the listener. So the order is completely not important. Some people do like to put their listen at the end. I know I do, but that's only convention. It's not important. It doesn't matter what order because it runs all the code first, and then things start to happen. So it didn't matter what order you did it in. So we can listen to other events. For example, .on. What's the other event we listened to in our snakes? Remember that one? What was it called? We listened for something when something came in. Data, exactly. Listen for data. And it's called data. And then we get a data object back. And like this. But we can't quite do it this way in a server because of this. This is someone connected, right? It turns out with a server, you get the client socket that connected. Someone connected, and this is who connected. It tells you who they are, maybe their IP address and other stuff, but you find out who it was that connected to me. And everything with that server, it happens in here. So in this case, this actually has to go here, and it's client on data if that client sends some data. This is probably the most common mistake when writing a socket server, either NetSocket or WebSockets, which we'll maybe talk about later on near the end of the program. It's the client. So if this client sends me data, then do the following thing. I'll just console log the data. There. I'll say client said, and I'll just say data. There. Okay. So once again, I can start my little server here. Oh, that's the wrong one. Where's the other one? There it is. Okay. Oh, start it again. Don't have NodeMon running, so I probably should do that, shouldn't I? Okay, now it's listening. And now if I connect again, great. Okay, so now I'm going to type something. I'm going to send it some data. Hello. There. I got something. The heck's that? But I did get something. I got some bytes because that's the default encoding type. It just sends, you get a bunch of bytes. Now I'm sure that's an H. I think a 48 is an ASCII H. Anyone know that? Anyone know their ASCII codes? I think that's an H. I think that's an E. I know that's a carriage and line feed for sure. I know that carriage and line feed. So I have a feeling it's saying hello there in bytes. So I need to tell my server, when you get data, you should treat it like printed text. Easy enough. We can just say anywhere here. Put it right here. Why not? Client dot, and we set the encoding, right? Set encoding. Can I spell that right? And there's lots of encoding ones, but UTF-8 is kind of the standard these days. TF-8. There's a bunch of them, and a lot of them would work here. ASCII, UTF-7 even. But UTF-8 is kind of universal. It's a great one to use. So now I'm telling the server, Oh, and server dot rather. I'm telling the server, when you get data, treat it like printed text. So now let's kill this again. Everything that happens for that client happens within this connection block. I forget that too half the time. So it is client-side encoding. All right, let's give it a try again. Cool. All right, let's do a connection. Okay, let's type something. Hello, server. Hello, server. Now I'm getting text. I can work with this now. Very cool. So that's a server. That's it. There's not much. Now we can do stuff. We can say if the person types maybe a command, we do stuff. But now we're getting into something else, aren't we? Now we're getting into what? We're getting into up here, the application layer. So if the client types, oh, get me slash, oh, that means the server would go, oh, okay, that means you probably want to get something. Now it just doesn't do anything, but now I'm talking some kind of language to the server, and the client and the server have to both understand that language, don't they? Now this server is dumb. It has no language. It's can't do anything. It just regurgitates back. I could suppose I could tell it to write what it said. I can go client dot write. Oops. There. And I can say, you said, you said, you said, and I'll just send back the same thing they sent, data. There. So now it's going to echo back whatever you said. That's annoying. You're annoying. You're annoying. Stop that. Stop that. And we have brothers and sisters that do that. That's just so annoying. Yeah. Okay. Anyway, so we have a very annoying server that will do that to us, like my little sister server. Okay. Stop this one again. Okay. Go in here. Oops. Side. Okay. Hello. Hello. Stop. Hey, stop that. Mom. Okay. So there we go. So a nice, that's our annoying server. Okay. That's our protocol we decided. And of course it says mom. You said mom, of course. Okay. So that's our protocol. It's an echo server. Really, it's a dumb protocol. You send something, it sends it back. But that's the protocol that we agreed on. I will send this. I'll send back what you sent back to me. Let's make ourselves a little server side because this or client side. This is pretty easy. There's not much to it, right? Let's make ourselves a client JS. Go to the file. We'll call it client dot. Yes, clients are actually simpler because we don't have to worry about listening and connections. We can do everything just in one connection. So a client JS, it'll also include net, pretty much the same. There. Okay. And we have to tell it what server to connect to. So we can say, get a socket const. We can call this socket server. It is a socket. We oftentimes see it called socket, but it really doesn't matter what you call it. Equals, and then net dot. And instead of create server, we're going to create a connection. Got this new keyboard that I just got a few months ago, and I've had the old one for like years and years, and this one is off by just 2 millimeters. It is driving me crazy. So you'll see lots of typos for the next probably 2 years until I get used to it. Okay. So create connection, and I have to tell what to connect to because now I'm the client. I initiate the phone call, don't I? Which means I'm going to be phoning or calling a server. So I need to know some stuff about that server. We talked about what do we need to know? Well, that's all I care about. Host, port, and protocol. I'm using TCP, so that's taken care of. Need to know what host it's at and what port I should use. So that's all I need to know. So create connection actually takes an object with the host and the port. Host and port. There. So we'll say host is, or port is 3000. We know that. And we'll go localhost, which is our computer. There. And this will be an object with curly braces. There and here. There. I could have made it a separate object. I mean, I could have done this. Why not? Let's make this an object. A little cleaner. Const, I'll call this a config equals that. There. And then create connection config. Same thing. Doesn't make much difference. Okay. And we know that localhost, that just means that's a special name for our computer. It actually translates into 127.0.0. Well, pretty much anything. In fact, it translates into 127 dot anything, really anything, but usually 0.0.1. But we tend to use the word localhost because it's just more friendly. Localhost, either one. Okay, so create connection to that. See what happens. Does that even work? Like, that's it. Really, one line of code, 2 lines if I break out my config, and now I've connected to the server. Let's try this. So I'm going to start my server again. There we go. And now we're going to go node.client. Have I forgotten something? Oh, I guess not. It connected. There, someone connected. Nothing's happening, of course, right? And I'll get out. Let's go back to my server. Let's have my server listen for when someone disconnects. Let's try that. So I want to find out when my server or somebody disconnects from me. And that'll be inside here again. It'll be another on, won't it? Client dot on. There. And what events can I get? Well, I have no idea. I'm going to go to the net thing. What are my events here? Events. Take a look. Up, go to the very top. There. Okay. So close connection. Okay. And where's my client connections? Here we go. So this is a client. So close connect. End. Oh, end. What does this happen? Emitted when the other side ends the transmission. That I want. Okay, this is good. When the other side hangs up on me, my program will know about that. Awesome. Let's take a look. So I'll go on end there. There. And I'll just console log. Client left. There we go. Let's try it again. Stop that. Start it again. And now when I start my client again, okay. And I stop it. Someone left. How easy is that? Really, this stuff is fun. And this is not difficult stuff at all. Net programming is actually really, really fun to do. And you'll discover later on we do WebSocket programming, which looks a lot like this. It's also really, really fun. It's kind of satisfying. You can go back and forth. Oh, it's working. It's like you're talking back and forth. And these two computers or programs can be anywhere. I could have this running anywhere, couldn't I? I could do that. And sometimes in my when I do my TCP lecture, what I do is I give everyone a copy of this code and I tell them my IP address and port. And you can see on the screen everyone talking to my server from all over Canada, wherever you are. It's cool. People do all kinds of stuff, sending me connections. It's kind of fun stuff. So the client and server programs can be anywhere. There's only one server and multiple clients can connect to it. And it works. All right. A couple more things. We're not going to do too fancy in our client, but we're going to add maybe something. We'll do a socket.on. And when it gets some data, same thing, data. There. We get a data parameter, so I'll put this here. Since there is only one, I don't need the parentheses in an arrow function, so I'll do it this way. There. And I'll just console log server says, just like we did in the snakes. Server says, and data. Very cool. So if the server says something, we're going to say something too. Very cool. Okay, and why don't we also detect if our server hangs up on us? We'll say socket dot on. If the server goes down for some reason, we'll also stop our program on end. There. And we'll also say something like, wow, take this and we'll just copy that. And server disconnected with no data. There. See what happens. See what happens here. First off, my server doesn't say anything, really, does it? Unless I send something. So my server is not really sending anything. We'll do that in a second here. But let's watch what happens even now. My server, there. Start my server, and now start my client. Let's kill my server. Ah, server disconnected. So now, it's great. And start up again. And if I kill the client, client left. Of course, the server didn't stop when that happened because it doesn't matter. But when the server connected, that's all this client has. It can't continue. The server stopped running. There is nothing the client can do. It's finished. It cannot, unless it reestablishes the connection, it's kind of game over. That's why, in this case, the program ends. Okay. In fact, I probably go process.exit like that. So it really ends. There. Try it again. So now if I kill it, now they both quit. Let's have my server, when it first has somebody connect, we'll have it send something. So we're going to send, I'm lazy, I always copy and paste. It gets me into trouble all the time. There. We're going to say client write. We'll just say hello. There. Hello. Say something. There. There we go. We're going to send that to our client now. So here we go. Start our server. It's always two, isn't it? Now, one thing I want to mention right now, remember this old thing, that VS Code terminal that we used to use? Anyone still use that? Those days are done. Okay, we will not be using this VS Code terminal because we're going to have 5 windows open pretty soon. This does not serve us very well. There's a couple of reasons we don't use it. But first off, it just takes up space of our code. And secondly, no one uses it. We don't use this terminal for much of anything. Because I can't see what's going on client server. So I would just close that and pretty much never open it again. We use real terminals now. And later on, we start doing browser software. It doesn't do a thing for us. Having this terminal open, nothing shows there. We start our server. It all happens on the browser. So I would, if you're still running it, I would close that off and start using real terminals. It will help you adjust later on when we start doing things in our client server software. Okay, so there's my listening. Great. Let's have our client connect. Server says, oh, look at that. Weird bytes. I think I need to have my client also recognize that the server is also sending text. So let's go ahead and say our server is also sending this UTF-8 stuff so I can understand it. Okay, try it again. Stop my server, which stops my client. Start it again. Oh, much better. Hello, say something. Really good. Okay. I could do all kinds of fun things. I could have it say, get something. But really, this is client server. It's kind of cool because when you do something on the client, you have to do the corresponding thing on the server to make sure it recognizes it. And in the same way, if you do something on the server, you got to make sure the client will recognize what you're doing. Okay, so I could do all kinds of things. I could say, where's my data? I don't know. Maybe if I get data, I'll say if, um, I'll have it get a number. If number, I'll convert data to a number. I'll assume the client's going to send me just a number. What's that? And I'll say equals 1. There. If the client sends me a 1, I'll send them something. Some cool text. There. Okay. And then I'll return. This is important. Otherwise, it'll drop through and do some more stuff. Okay. Okay. So if they send a 1, I'll send them some text. Let's try that. So now we're building out like an application protocol, aren't we? Now we're going up the stack. Now we're talking about this. How do the client server talk to each other? And that's what all this stuff is. Really, the presentation application layer, it's application. How do these two applications talk to each other? What I've said is, if the client sends a 1, it's going to say some cool stuff. And I'm going to go ahead and stop and start my server. Start that, and I'll start it. And I'm going to go to Telnet. Go back to Telnet. Oops, on this side here. Telnet. Say something. I'm going to go 1. Ooh, some cool stuff. The protocol works. Yes. I love the term. They always use the word protocol in like TV shows, like it's a word. Like, here's the protocol. Here's the protocol. Yeah, it's stick to protocols or disaster protocol. It's like, and sci-fi, every second word is protocol, isn't it? That's what it means. This means we've agreed to do it this way. That's all a protocol means. Something we've agreed on. So if I send a 1, it's going to send me some cool text. That's the protocol. Okay. All right. So that's really TCP as far as we're concerned. Client server, and the TCP stuff really works down here with ports and IP addresses or hosts and network protocols, TCP, UDP. Don't do a lot of it, but it is pretty fun stuff. As I mentioned, we'll be doing WebSockets a little later, and that is super fun. Then we can actually write real web games. Let's talk a little bit more about this, because starting in a few days, we'll be doing actual applications. And very likely we'll be using HTTP, the HTTP protocol. So I'm going to go ahead. I'm going to talk to a server. There. Now, I've talked to mine. Let's talk to another server directly using TCP, because they all do that. So for instance, the HTTP protocol, which is what we're all going to use. There. How about application protocols? Not to be confused with network protocols. Network protocols are TCP, UDP, and a bunch of others. But application protocols, there's hundreds of them. Hundreds of them. Take a look. There. Application protocols. I just cannot spell. Take a look. Yes, there are a lot of application protocols, and that's only a few. Let's take a look. They show us all. There's thousands of them. Here's the ones that we kind of deal with the most. DNS. We all use that. Anyone know DNS is? Anyone heard the term DNS? It stands for Domain Name System. All that does, it converts names to phone numbers. Google.com converts that to something, right? SMTP, email protocol. FTP, POP, which no one uses anymore, but it's still there. And of course, the hypertext. I love that word, hyper. This is the 90s, right? It seemed really cool having those white pages with black text and blue links. They were called, anyone know what are those blue links called? Hyperlinks. I know it's funny now. They were called hyperlinks, blue text. So it was called the hypertext transfer protocol. You get a page and it shows it. You can click on a link and get another page. HTTP, which is what we inherited. There's versions of it, but this is the one we will use. And HTTP has a particular language. It's a protocol. It's a way they've agreed. So HTTP, of course, and other ones, DNS, which we cannot live without. If DNS goes down, the world stops. Seriously. And this has happened. We've had Rogers or Shaw or TELUS, when their DNS server goes down, nothing works. Because this is what converts google.com to an address that we can use to connect to. And SMTP, SSH, which I use a lot, FTP, there's hundreds of them. They all tend to have their own ports, interestingly enough. So if you're talking port 80 or 443 or a couple of other ones, 8443 and some other ones, it's assumed that you are talking HTTP. If you're talking on 53, actually it's UDP or TCP, it's assumed you're talking DNS. SMTP, port 25, or some other ones as well, two others. SSH 22, FTP is kind of weird. Talk about FTP, it's kind of a strange one. So these are generally accepted protocols for these ports. So if you're talking this, it's assumed you're talking HTTP. Okay, so let's talk to a server. There, go telnet. I'm going to talk to a server. HTTP. I want to talk to Google. Let's talk directly to Google over low-level TCP/IP. Let's try this. So www.google. I'll do CA and 25 because I know, oh, sorry, it's port 80 because I know that HTTP is port 80. Let's see what happens. Is it going to connect? It connected. I connected. I'm talking to Google directly. I've got a direct pipeline into Google. How awesome is that? Well, it's not that exciting really, but it's pretty cool. It's waiting for commands. The HTTP protocol means that it's going to wait. It's not going to say anything. It's going to wait for me to do something. And I believe I have to type in get space slash space, and then also I'm talking HTTP colon or slash 1.1. I think that's how we do it. See what Google says. Oh, very cool. No idea what that is. Looks a bit like a web page, though, doesn't it? A really, really big web page. What the heck? With a lot of CSS. Oh, this is huge. I can't even vote. Hold on. There it is. Okay, so there's my response from Google. It says, okay, we'll talk about this when we start doing our HTTP stuff. Have we started yet doing our HTTP request stuff yet in Compass? I think we might have. 200, okay. Then it gives me some stuff, and then it gives me a page, like a page. There, some web page. But look at that. I talked to Google, and Google answered me. I feel so special. Okay, so this is the application protocol we talked, which was HTTP, and that's the very next thing we're doing in Compass is HTTP. That's why we start you off with a TCP and net to kind of understand how the software works or talks to each other at this TCP level, and you can pick any arbitrary protocol. Ours is just annoying echo protocol. And then you can look at some application protocols like HTTP. All right, everyone. That is our talk for today. Thank you for coming. I know I think this was rescheduled, so I apologize for that. So thank you for coming on this notice. This is fun stuff, and it gets much more fun. All right. Okay.
Thanks for your
Have a
time,
great,
Gary.
yeah, have a great rest of your Saturday.
Thank you, you too.
Everyone soon.